Welcome. This video is going to go over some solutions to paper 2 questions regarding equilibrium from chapter 7. The diagrams below represent equilibrium mixtures for the reaction y plus x2 yields xy plus x at 350 and 550 Kelvin respectively. Deduce and explain whether the reaction is exothermic or endothermic. For 2 marks, what you should notice is if I look for x, which is a pretty easy to identify product here, I start with 3 at the lower temperature, and with the higher temperature, my product decreases. So an increase in temperature is decreasing product. And what that tells me is that heat is driving the reaction left, so it must be like adding a product that it drives it left. And so this is exothermic, since product decreases with heat. The first part of number 11 asks you to outline the characteristics of a homogeneous chemical system. Now, homogeneous we didn't talk about a lot, but any chemical system at equilibrium is going to have several things in common. The forward and reverse reactions have equal rates. The concentration of the product and the concentration of the reactant remain constant. That doesn't mean they're equal to each other, but they're not changing. It has to be in a closed system. It can be reached from either direction, or either side. We can say you can start with reactant or product, and you'll end up at the same equilibrium. Macroscopic features or characteristics don't change, so appearance is same. And then the homogeneous is just saying all reactants and products are in the same state. And you needed 2 of those. I've rewritten the equation here that they gave you for the beginning of 11. And it says deduce this expression for the equilibrium constant Kc. So Kc for this equation would be equal to the concentration of Hi squared divided by the product of the concentration of H2 times the concentration of I2. Pretty straightforward for 1 mark. Predict what would happen to the position of the equilibrium and the value of Kc if the pressure increased from 1 to 2. So position, first of all, would be no change. Kc would also be no change. And the reason why is because you have equal moles on each side. So because there's 2 moles on the reactant side and 2 moles on the product side, neither side is more crowded or going to see a greater benefit or relief from changing pressure or volume. Number 4 says the value of Kc at 500 is 160 and the value of Kc at 700 is 54. Deduce what this information tells us about the enthalpy change of the forward reaction. So what I notice is that Kc increases with temperature. If Kc increases, that means the concentration of product increases. And if product is increasing, that means temperature is driving the forward reaction, and this must be an endothermic reaction. The 5th part of the question says the reaction can be catalyzed by adding platinum metal. State and explain what effect the addition of platinum would have on the equilibrium constant. And I'm just going to take a look at how many marks this is worth. It's worth 2, as they often are, because they want you to not only indicate that Kc is not going to change, but the reason why is because a catalyst affects rate only. Affects the forward and reverse reaction equally and does not affect the amount of product made or the yield. Then on the question number 12, again, I've written the equation over here because the test didn't print out very user-friendly, but your first thing you're asked to do is determine the equilibrium constant. So Kc is going to be equal to NH3's concentration squared divided by the product of N2 times H2 cubed. State and explain the effect on equilibrium yield of ammonia with increasing the pressure and temperature. Well, this is really two different questions, which is why this is 4 marks. State and explain it for two different conditions. Increasing pressure is going to crowd reactants more. It's going to crowd both sides by increasing the pressure, but it's going to crowd reactants more. So it's going to shift left or increase yield of ammonia, since that's the product we want. The temperature, increasing the temperature, is going to favor the reverse reaction, because this is exothermic. And that means my yield is going to decrease as a result. Part 3, in practice, typical conditions used in the Haber process involve a temperature of 500 and a pressure of 200. And these both are considered kind of moderate conditions. Explain why these conditions are used rather than those that give the highest yield. And 2 big reasons for it. Well, actually 3 you could get into. The 500 degrees doesn't decrease the rate so much, still keeps rate still keeps okay with an okay yield, because we want the higher temperature for the rate, but we don't want the higher temperature for the yield. The 200 atmospheres and the 500 degrees both keep things at a decent cost. Cost is bearable and safety is doable under these conditions. Much higher for either temperature or pressure, and the cost goes way up, as well as safety concerns. Part 4 says, at a certain temperature, 1.1 decimeters cubed of N2 and 3.3 decimeters cubed of H2 are reacting. Calculate the volume of NH3 produced. This goes back to Avogadro's principle that 1 mole of gas is the same volume no matter what kind of gas it is. So when I look at this 1 to 3 to 2 ratio, that also goes for my volume. So 1.1 and 3.3 will yield 2.2 decimeters cubed, or liters. Suggest why this reaction is important for humanity. It's all about producing enough food for 7 billion people. And lastly, for 2 points, 2 marks, they're asking you 2 different questions. Chemist claims to have developed a new catalyst which increases yield. State the catalyst normally used. So, and then comment on the claim made. So the catalyst normally used is iron. Now, I don't think the new, kinder, gentler IB is actually going to ask you for the name of the catalyst, but who knows? Iron's not that hard to remember. You might get lucky, just guess a metal. How about the claim? The claim is false, because there is no catalyst out there that increases yield. Catalyst affects the rate.